Yeah, good evening everyone. Good evening. Good evening. Good evening everyone. Good evening. Yeah, let me write here. Let me write here. So date is today, I think 6 maybe. Today 5 or 6. I think today date may be 5. Yeah, 5, 8, 25. This is the today's date. Yeah, same. Today's date is 5/8/25. Subject name is a compiler design. So marks you are going to get is, I think, minimum 6 marks, maximum 10 marks you are going to get. So ending date also I am giving. Ending date mostly 25. Mostly ending date is 25. I am writing here. So I am writing here. Mostly ending date will be, I am thinking the 25/8/25. On this date, mostly this subject will be over. Then we will start the new subject. So starting date is today. I am starting at the 5th. 5th I am starting compiler design. 6 to 10 days it will take. Sorry, 6 to 10 marks it will give. So ending date is 25/8/25. Right? This is the ending date. So let me write the syllabus. Let me write the syllabus of compiler. Let me write the syllabus of compiler. The first chapter is lexical analyzer. First chapter is lexical analyzer. First chapter is lexical analyzer. Second chapter is syntax directed. Second chapter is parser. First chapter is lexical analyzer. Second chapter is parser. Third chapter is syntax directed translation. Fourth chapter is I can go for intermediate code generation. You can write whatever order you want, there is no objection. Intermediate code generation. So fifth one is runtime environment. So fifth chapter is a runtime environment. So sixth chapter is code optimization. So sixth is over. Seventh one, live variable analysis. Live variable analysis. Right, these are the 7 chapters. First one is lexical analyzer, second one is parser, third one is syntax directed translation, fourth one is intermediate code generation, fifth one is runtime environment, sixth one is code optimization, seventh one is live variable analysis. So these are the 7 chapters. These are the 7 chapters. So, and let me say one more thing also. right? So this lexical analyzer will give 1 to 2 marks approximately. Parser will give 2 to 4 marks, maybe sometimes 5 also. Minimum 2, maximum 4. Syntax directed translation will give, I think this is also will give 2 to 4 marks. Intermediate code generation, it will give, I can say 1 to 2 marks. Runtime environment, it is also 1 to 2 marks. Code optimization, it is also 1 to 2 marks. Live variable analysis, this is also 1 to 2 marks. Right? So minimum marks of this subject is going to be 6 marks, maximum 10. Right? So compiler design is going on. Simultaneously morning discrete mathematics is going on. You can complete discrete mathematics also. Morning live discrete mathematics is going on. Compiler design evening you do. Morning you can do discrete mathematics. Right? Afternoon if you want you can do some other subject also. No objection at all. So compiler design. So syllabus is this. Right? So we can start the first chapter lexical analyzer. Before the first chapter, let's go for introduction to compiler. First chapter before the lexical analyzer. So let's go to the introduction to compiler. Introduction to compiler. Before the first chapter, this is the introduction part. Introduction to compiler. Introduction to compiler, right? Before the first chapter, this is the starting point. So before proceeding further, let's see audio video okay or not. Yeah, what are you going to do? Yeah, so Tarab saying that good morning, sir. Tarab, yeah, good evening. Yeah, thank you. Thanks everyone. Thank you everyone. Let me know audio video okay or not. We are starting now. Let me know audio video okay or not. Everyone try to catch it. Audio video okay or not, please verify. One time say good evening. One time say good evening everyone. One time say everyone good evening. Good evening Mohit. Mohit, good evening. Tarab, good evening. Everyone, good evening. This is the correct time to start. Introduction to compiler. This is the correct time to start introduction to compiler. Yeah, let me start now. Everything is ready. Everything ready in my opinion. Syllabus is, in my opinion, class is just started now. In my opinion, class is just started now. So I'm going back and I'm just summarizing once because some people came now only. Just I am summarizing. Can you see this one? Those people who came late. So can you see this one? Can you see everyone? So today's date is 5/8/25. Compiler design is the subject which we are starting. So you are going to get the minimum 6 marks in this subject. Maximum is 10 marks. The syllabus, if you see, lexical analyzer, parser, syntax directed translation, intermediate code generation, runtime environment, code optimization, and live variable analysis. So lexical will give 1 to 2 marks. Parser will give 2 to 4 marks. Syntax directed translation will give 2 to 4 marks. Intermediate code generation will give 1 to 2 marks. Runtime environment will give 1 to 2 marks. Code optimization will give 1 to 2 marks. Live variable analysis will give 1 to 2 marks. Okay, fine, perfect. Now we are, before going to start the first chapter, introduction to compiler, we are starting some basics. After basics are over, then we will go to the first chapter. It is the introduction to compiler. I'm starting now. Everyone, please be careful. Everyone, please be careful. Be careful, everyone. Introduction to compiler. Right? Be careful. See this? See everyone? See everyone? The program normally, whatever we will write as a human, as a user, the program which normally we will write is, that program is there in the high level language. The program, whatever normally we will write, that is there in the high level language. See this one? User program is in high level language. User program is in high level language. Now this is the input to the, this will be the input to the preprocessor. This is the input to the preprocessor. This is the input to the preprocessor. User will write the high level language high-level language program that will be given as the input to the preprocessor. What the preprocessor will do is, it will take high-level language. What the preprocessor will do is, this will take the high-level language as input. It will convert into pure high-level language. Pure high-level language it will convert. So preprocessor will take high-level language as input. It will make it as pure high-level language. The meaning is, in the high-level language, there may be some shortcuts. In the high-level language, there may be some shortcuts. What the preprocessor will do is, it will replace all user-defined shortcuts by actual. All user-defined shortcuts by actual. In the high-level language, shortcuts may be there. In the pure high-level language, there is no shortcut. So preprocessor will take a high-level language as input. It will convert into pure high-level language. I think you see in the newspaper or digital media, you may see that pure ghee. Some companies are selling pure ghee. It is not ghee. Pure ghee means no culti. They want to say that no culti. So if you see the digital media, or if you see the news channel, or you see the newspaper, so you will see some companies are selling pure ghee or pure dahi. They want to say that there is no culti. There is no culti. So similarly here also, high-level language has input to the preprocessor. Preprocessor, what it will do is, it will pre-process. If any shortcuts are there, it will replace by actual. So then high-level language becomes a pure high-level language. High-level language become pure high-level language. I will give one example also within few minutes. First, let's understand. Preprocessor will take high-level language as the input. It will produce pure high-level language as the output. Now that will be input to compiler. That will be input to the compiler. So you know very well it's our major story. Our major is what? Compiler design. This is our major. But anyhow, let me introduce once. Let me do introduction once. So compiler. For compiler, input is going to be pure high-level language. Compiler input is going to be pure high-level language. Compiler input is pure high-level language. Then compiler input is pure high-level language. Output, if you observe, output of the compiler, if you observe, it will convert the high-level language into low-level language. Low-level language. It will convert into high-level language into low-level language, which is also called as machine language. Which is also called as machine language. Which is also called as machine language. Low-level language or machine language. Compiler input is pure high-level language. Output is going to be low-level language, which is also called as machine language, which is also called as low-level machine language, which is also called assembly language. Assembly language. Compiler input is pure high-level language. Output is going to be low-level language, which is also called as a machine language, which is also called as a assembly language. So that will be input to the next phase, next person, assembler. Next one is assembler. That will be the input to the assembler. Compiler will take a pure high-level language as an input. It will produce low-level language as output, or machine language as output, or assembly language as output. So that will be the input to the assembler. Assembler will take assembly language as the input. Assembler will take assembly language as the input. It will produce relocatable. Whatever previously, now also same. Relocatable low-level language. Or one more name. Relocatable low-level language, or relocatable machine language. Or one more name. Relocatable. Just whatever previously, just add R. Relocatable assembly language. Assembler input is going to be assembly language. Output is going to be relocatable low-level language, or relocatable machine language, A relocatable assembly language, that will be the output of the assembler, right? What exactly meaning? I will definitely within a few minutes I will clarify. Just let me go in one way. Let me go in one way, right? I will clarify all your doubts. I will clarify all your doubts. Assembler input is going to be low level. Output is going to be relocatable low level. A relocatable machine language. A relocatable assembly language. So now that will goes to as the input to the linker. Right? For the linker input is going to be relocatable low level language, a relocatable machine language, relocatable assembly language. That is the input to the linker. So what the linker output is? Linker output, if you observe clearly, it will name itself saying linker. It will link. It will link. So what I mean to say is, whenever, careful everyone, whenever a project is running, definitely all is associated files required. Whenever a project is running, all associated files are required. So what the linker will do is, it will group. Whenever so many files are there, let us assume that in your computer there are 50,000 programs. Let us assume that in your computer 50,000 programs are there. When you click on a particular program, compile, then what happened is, in that folder, right, in which folder there is a program where you done the compile, then what happened is, right, so to that particular program, which are associated programs, they all will be linked together. When you say compile, then what happened is, not only which file you are compiling, it will go, all associated files also should go, otherwise problem will come. So linker will do that. Linker will link it. Even though you done the compile on a particular file, then what happened is, all associated files will also go for compilation. All associated files will go to compilation, otherwise problems will come. So linker will link all associated files as one file. It is something like this. In the Google, you are searching some XYZ, all XYZ related stuff will come. In the Google, if you type some ABC, all the things which are related to ABC, they will come. In the Google, if I type India, all the things which are related to India, it will come. Similarly here, if you do on any program compile, then that program associated things all will come as a one bundle, as a one group. That is the purpose of linker. Linker will link. So previously relocatable low level language, now see this one, multiple relocatable low level language. Previously what happened is only one. What the linker will do is, all associated things, it will make it as one group, relocatable low level language. Right now it will become multiple relocatable low level language. All associated things, they will group together, they will make it as one bundle. When you say compile on any program, when it is going to compilation, all associated things also will go. So how you know who are associated, who are not associated? That will be decided by linker. Linker will link. Necessary things will link. So multiple relocatable assembly language are same thing. Multiple relocatable machine language are multiple relocatable assembly language. Same thing, whatever previously, now also same. Previously one person, now because of linking you done, all associated things will come as a group. So I'm repeating once again. So see, everyone understand here. So a high level language program is input to the preprocessor. It will make it as a pure high level language. Right, next one, compiler will take pure high level language, it will make it as a low level language. Right, next one. So let's see one interesting story. See everyone, now in which program, understand everyone, in which folder your program is there. on a particular in a particular folder, there is a one program. On that program you done compile. Then what happened is all associated things also will compile. So let us assume that here multiple high level language things. So here multiple pure high level language also there. So compiler, multiple low level. Why I am doing, you will get to know. Multiple low level. It is a multiple relocatable. Now what the linker will do is it will group together all the necessary things as a single bundle. So this is going to be single relocatable assembly language. It will make it as a one group. It will link single relocatable, right? Relocatable low level language. Single, right? So let me write now. Single relocatable machine language. All associated things it will group as one. That's it. All associated things it will group it as one. You may say that, sir, what are the things it will make it as a single, sir? All associated things. All associated things. You no need to confuse. For your convenience, I written multiple and all. Simply linker will link it. For your convenience, I written linker, right? For your convenience, I written single, multiple, right? Linker will link it. That's it. Now again, let me talk normal way. Preprocessor input high level, output pure high level. Compiler input pure high level, output assembly language, low level language, machine language. That is the input to the assembler. Assembler output is, right, relocatable low level language, a relocatable machine language, relocatable assembly language. That is the input to the linker. What the linker will do is it will link it. The things which are related to your program, on which program you said compile, on which program you said compile, right? That program all associated things. You will make it as a one group. Single relocatable low level language, single relocatable machine language, single relocatable assembly language. Just try to understand here. Linker will link all the associated things as one group. Linker will link. Simply say linker will link it. Right? Fine. I think within few minutes I will give one example. Everything will be clear. Now that will be, listen, that will be the input to the loader. Loader, what it will do? It will load a program. If you want to compile, right, after compilation, next you have to run. If you want to run the program, that program should be there in the main memory. Remember, loader will load the program from the hard disk to main memory. Right? Loader will keep the program in the main memory. Loader will load the program. Finally, your program will goes to main memory. Finally, your program now present in the main memory. Loader will load the program from hard disk to main memory. Let me write now. It will load. It will load. Program from hard disk to main memory. It will load the program. It will load the program from hard disk to main memory. So try to catch this. One or two difficulties may be there. Within few minutes, I will handle. Within few minutes, I will handle. Preprocessor, see, multiple keyword may not be there. Right? In the books, if you observe, multiple keyword may not be there. For your convenience, I written. Preprocessor input, low level. Sorry. Preprocessor input, high level language. Output, pure high level language. So then what it will do? It will remove some shortcuts. In the high level language, some shortcuts are there. It will remove those shortcuts. Now that will be input to the compiler. What is the compiler output? Right? Low level language, machine language, assembly language. Right? Next one, assembler. Assembler will take assembly language as input, output, relocatable assembly language, relocatable low level language, a relocatable machine language. Now that is the input to the linker. Linker will link it. The things which are associated to this particular program on which you set the compile, it will link multiple as a single. It will make it as a, right? It will take all the necessary thing. It will make it as one single group. Single relocatable, right? Single relocatable low level language, or single relocatable machine language, single relocatable assembly language. Now that is the input to the loader. Loader will load the program from right hard disk to main memory. Now at the end of the story, your program is there in the main memory. When you say this, your program, whenever you say this entire story is over, your program is there now in the main memory. Whenever this entire story is over, now your program is there in the main memory, right? Because if it is there in the main memory, you can run the program also. Next step is running only. Compilation followed by running. Now you can run the program. Because your program is there in the main memory, you can run the program. Compilation is over. Now program is there in the main memory. From there, you can run the program. From there, you can run the program, right? These are the things which are associated here. Yeah, let's see your comment section. There may be some doubts. Let's see your comment section. Yeah, any doubts till now? Within few minutes, I will clarify few more, right? Within few minutes, I will clarify little more better way. Within few minutes, I will clarify little bit better way. Check everyone. Everyone have to check. Check everyone. Any doubts? If any doubts, let me know. If any doubts, let me know. Can we move to next? Hello? Can we move to next? Yeah, now you can see this. Right? Now I got to know no doubts are there. No one having any doubt. Now I will clarify few more things. Understand everyone. Everyone, please careful. Understand everyone. What is the high level? What is the low level? I will just do small description. I will say small description. What is high level? What is low level? Please see this. Please see one small line. A is equal to, careful, B plus C. Or otherwise, if I want to say easiest way, I will say this. Careful everyone. A plus B. This is called a high level. A plus B is a high level. Right? Add R1, R2. Keep the A and B both in the register. Afterwards, write add R1, R2. So remember, this is called as high level language. This is called as a high level language. This is called low level language. Right? So preprocessor will take a high level language. It will produce pure high level language. High level only, but the shortcuts are there, it will remove. But remember, this is the difference between high level, low level. A plus B, high level. Add R1, R2, low level. Add R1, R2, low level. Right? Add R1, R2, low level. Try to understand. This is high level, this is the low level. Okay, that is okay. Now, one more thing I want to say to you. Listen, high level to low level, that is okay. Some people are asking, sir, what assembler will do? You just listen this also. What assembler will do? So you compile the program, okay. Afterwards, you have to run the program. You compile the program. Afterwards, you have to run the program. But remember, initially program is there in the hard disk. Right? But if you want to run the program, it should go to main memory. It should go to cache memory. Means your program should move from one memory to another memory. Remember, your program should move from, if you want to run the program which is there in the hard disk, you want to run that program, it has to go to main memory. It has to go to cache memory. So if you want to run the program, it has to go to different memories. So you have to, when you are going from one memory to some other memory, right? One memory storage to some other memory storage, definitely different memory storages are having different behaviors. What the assembler will do is, it will take the program which is there in the hard disk, right? It will convert that program into relocatable low-level language. You see this one. Here also low-level language there. Here also low-level language there. Both are low-level, relocatable. It will allocate the power to the code which is there in the hard disk in such a way that it can move to any memory. Relocatable low-level language. It can relocate. Assembler will give the power to move code from one memory to another memory without losing anything. If you remove the assembler, you cannot move the code from one memory to another memory. If you do that, you may lose, right? You may lose some content. So assembler got to know one interesting thing. What is that one? Oh, you want to run the program. So program is there in the hard disk. You want to run the program. Oh, it has to go to main memory. It has to go to cache memory. Okay, it has to go from one memory to another memory. So if you send it directly without taking any precaution, there may be chance that your program may damage. So assembler will take all the necessary actions. Assembler will take assembly language as an input. It will produce relocatable assembly language. So what is the meaning of relocatable is, it is giving the power to the code. You can move wherever you want, right? And the important thing is, we are already taken the precautions. You don't lose anything. So before assembler also low level, after assembler also low level, but previous low level you cannot relocate. But after assembler you can relocate. So relocatable low level language. Before assembler, low level language. After assembler, relocatable low level language. So it is giving the power to the codes in such a way that you can move from one memory to another memory. Relocatable low level language. Okay, that is also okay. Now I will give one simple example so that you will get the more clarity. Sir, Reddy sir, what is the meaning of relocatable? I given one example, right? You want to go from one memory to another memory, you cannot keep directly. So you have to convert. With the help of assembler, you have to convert so that you don't lose anything. Simple example. You want to go from India to US. You want to send, right? Or you want to go from India to US. If you want to go from India to US, remember, you should have passport. You should have passport. Or you should get a visa, almost like a visa kind of thing. You want to go from India to US. Without visa, you cannot go. So they are given visa means, right? They are already verified. Can he stay in the US or not? He is an Indian, right? He is going to US. Can he stay or not? If at all they confirmed that you can stay without having any problem, then only they will give visa. Otherwise, they don't give. So visa, you got the visa to go from India to US means, right? You are relocatable. You can relocate from India to US because they are already taken precaution in the visa, right? Interview process, they are already asked the things which are necessary. They got to know that you can easily survive in the US. That is the reason they are giving the visa to you. Otherwise, they don't give visa. They will check, do you have money or not? In the visa interview process, they will verify also, do you have enough money or not to stay in the US? Or will you go from India to US, there will you beg? They will check. Suppose isn't that you don't have any amount in your account, they don't allow you to go to US. So you have to show some bank balance. And one more, you are Indian, you want to go to US, they will check, do you know proper language or not? Otherwise, their communication problem will come. So I want to say indirectly, directly, assembler is nothing but visa. Visa people, whatever they will verify, assembler also will verify same way. So you got visa means you can relocate from India to US. Similar way here also. Assembler is completed means your code can go from hard disk to main memory, hard disk to cache memory. It can go anywhere. That is called relocatable low-level language, a relocatable machine language, a relocatable assembly language. That is the input to the linker. So what the linker will do is multiple relocatable files are there. Linker will link it, which are necessary. So linker will link it. It cannot link all. Unnecessary things it cannot link, because in your hard disk so many files are there. It cannot link all of them, which are necessary. In the hard disk, there are 50 files are there. 50 multiple relocatable low-level language files are there. What the linker will do is, which are necessary, it will make it as one group. I will give best example so that you will remember many days. Let us assume you want to go from India to US. You got visa also. You want to go from India to US, you got visa also. Tomorrow morning 6 o'clock you have flight. Today night, if I observe, tomorrow 6 o'clock there is a flight. There is a flight from India to US. You got the visa also. Means you can relocate also. Today night, if I observe, right, you will take one very big bag, right? In your house, so many clothes are there. You are keeping necessary clothes in the bag. In your house, there are so many chargers are there. Cell phone chargers. You are taking your charger. You are keeping in the bag. Right? In your house, so many phones are there. You are taking your phone. You are keeping. So what I want to say is, packing is going on, which is nothing but linking, which is nothing but linker. Packing is going on. Linker is nothing but packing. Tomorrow morning 6 o'clock flight is there. Tomorrow morning 6 o'clock flight. Today night you are doing packing, which is nothing but linker. What the linker will do is, all the related things, it will make it as a one group. It will make it as a one single package. Then you will take that bag and you will go to airport. Same way here also. Linker will link multiple relocatable low-level language files as single relocatable, right? Single relocatable low-level language files. So out of so many phones in the house, you will take only few things you will keep in your bag. Out of so many clothes in your house, you will take only few clothes you will keep in your bag. So linker will link it, all the necessary things, as a single bundle. It is exactly like that. So after everything is ready, then you will go to tomorrow morning 6 o'clock to airport, right? From India, you will go to US. So that's what the loader will do. Loader will load the program from hard disk to main memory. Loader will load the program from hard disk to main memory. Try to understand. Right? Try to understand. So finally, your program is there in the main memory. Initially, it is there in the hard disk. It is there initially in the hard disk. Now it is shifted to main memory. So try to understand, everyone. So are you okay? Bro, are you comfortable till now? Check anyone having any doubt? Now you got the clarity. Multiple high level language, right? So initially high level, preprocessor will take, it will make it as single, right? It will make it as a, sorry, so I'm repeating once again. Preprocessor will take high level, it will make it as a pure high level, that is input to the compiler. So it will convert into low, right, assembly language or low level, that will be the input to the assembler. So that is the reason it is called assembly language. You can remember like this also. Assembly language input to the assembler. That is the reason how this name is kept. Assembly language is the input to the assembler. Assembler will convert, right? Assembly language relocatable. So before, if I remove the assembler, the code which is there in the hard disk, you cannot move to main memory. You can do, there may be some damage. So assembler will convert, right, normal assembly language into relocatable assembly language. So that will be input to the linker. Linker will link it. The associated things all, it will make it as one group. When our total packing is done, you take that bag and you go to airport. From the airport, you can go to India to US, right? So loader will load the program from hard disk to main memory. Okay, that's okay. So this is called as a high level language. This is called as a low level language. High level, low level, that is also okay. Let me say one more small line. Let me say one more small example so that you will get the clarity. Can you see this? Can you see this one? One small thing. Careful, everyone. Has defined, the C programming, there is a one keyword. Has defined square of x is equal to x into x. Just I'm giving one example so you will get the clarity. As defined, square of x is equal to x into x. As defined, square of x is equal to x into x. Okay, fine. Now see the main program. Now see the main program one time. Main. As defined, square of x is equal to x into x. Main int y comma x is equal to 4. Now y is equal to 64 by square of x. Printf x comma y. Can you try what is the output of this program? Can everyone try what is the output of this program? As defined, square of x is equal to x into x. So main into y comma x is equal to 4. Y is equal to 64 by square of x. So printf x comma y. Printf x comma y. Can you try this? Can you try what is the output of this program? Try this. What is the output of this program? Everyone have to try. Everyone have to try. What is the output of this program? What is the output of this program? Try everyone. Let me know the answer. Let me know the answer. As defined, square of x, x into x. So main into y comma x is equal to 4, y is equal to 64 by square of x, printf x comma y. Can you try? I will give the answer. Can you try? Okay, now I am giving answer. So many times I said to you. So let's check here. Listen, let's check here. Remember, see this one. This is a shortcut. Remember, this is the shortcut. This is also called as a macro definition. This is also called as a macro definition. This is called macro definition, right? So see this one. This is the shortcut, which is also called shortcut. This is the shortcut. This is a shortcut. So what happened is, listen, whenever pre-processing going on, understand everyone, whenever pre-processing is going on, what the pre-processor will do is, right? Whenever pre-processing is going on, what the pre-processor will do is, it will replace all shortcuts. Remember, it is a shortcut. Square of x is a shortcut. It is a actual. This is the shortcut. This is the actual. What the preprocessor will do is, whenever pre-processing is going on, it will go inside the program. It will identify where is the shortcuts are there. If the shortcut replaced by actual. Actual is x into x. In the program, wherever shortcut is there, it will replace shortcut by actual. It will replace, right? It will replace shortcut by actual. So some people are saying, who is doing preprocessor? Preprocessor. Remember, before compilation, preprocessor will execute. What the preprocessor will do is, it will replace shortcut by actual. In the program, wherever shortcut there, it will replace by actual. After replacing all, this shortcut will be deleted. After replacing all shortcuts by actual, what the preprocessor will do is, replacements all done, it will eliminate the shortcut. The shortcut, whatever is there, it will eliminate. Now I think it will goes to further rounds. But if you want, you can run this one. If you run this one, what will happen is, y is equal to 64 by, right, everyone knows square of x means x into x. X is 4 into 4. X is 4 into 4. It will replace shortcut by actual. Actually, shortcut is square of 4. X is 4. Square of 4. It replaced by 4 into 4. Square of 4 is replaced by 4 into 4. Now, I think now priority concept will come, because whenever running is going on, processor will come to the picture. So he will run the program. So see the program. I think everyone know multiplication and division both are same priority. Associativity is left to right. Multiplication and division both are same priority. Associativity is left to right. So left one should be done. 64 by 4 is 16. Afterwards 16 into 4. So again 64. So y is 64. So x is 4 only, no change. Y becomes 64. So what I mean to say is, what the preprocessor will do is, it will replace all shortcuts by actual. All shortcuts by actual. Some people are asking, sir, this is there, shortcuts also there. Then what is the name of that language? What is the answer? High level language. Right? See, shortcut is there. And see this one, has defined square of x into x. So it is there, square of x also there. This is called high level language. Now I will replace shortcuts by actual. Supposition that this is deleted. Square of x written by x into x. That is called pure high level language. This is called pure high level language. Try to understand. I want to say to you, what is the meaning of pure high level language? This is the meaning of pure high level language. Replacing shortcuts by actual. Who will do that? Preprocessor. Who will do that? Preprocessor. Right? Preprocessor will do that. So try to understand, preprocessor will do that. It will replace shortcuts by actual. So I hope I explained everyone. Preprocessor will take high level language. It will produce pure high level language. That is input to the compiler. Compiler will produce assembly language, low level language, machine language. First of all, what is low level language? This is low level language. What is high level language? This is high level language. Now this is given to the assembler. What assembler will do? Assembler will keep the same code only, but it will give the ability to reallocate. Assembly language, whatever assembler is having, so it will produce the same thing only, but relocatable. It is taken some precautions. So it is giving the ability to move the code from one memory to another memory. Assembler will take assembly language as input. Output is relocatable assembly language. You can relocate the code, whatever is there in the hard disk, it can go to main memory, it can go to cache memory. Now that will be the input to the linker. What the linker will do? It will link it. All the necessary files. It is exactly like packing. Tomorrow I am going to US. Today night in my room I am doing packing. That is exactly linker. Linker will link all associated things as a single file. So single relocatable low-level language. Previously, multiple relocatable low-level languages are there. Now, out of those multiple, it will take few which are linked together. It will make it as a single bundle. Now packing also ready. Now go to the airport. From there, you go to the US. So loader will do the remaining formalities. Loader will load the program from hard disk to main memory. Now, what exactly preprocessor will do? It will replace shortcuts by actual. It will replace shortcut is the square of x. Actual is x into x. It will replace shortcut by actual. Right? I think now just one small question I want to ask you. Now, where is the program? One small question I want to ask you. Where is the program? Please help me. Where is the program? I want answer from all of you. Where is the program? Please make it fast. Where is the program now? Now program went to the main memory or not? Loading is done. Loading is done. Where the program went? Program went to main memory. From there running will start. From there running will start. Program will go from hard disk to main memory. Loading is done means your program is there in the right main memory now. From main memory you can run the program. Until now, any objection, let me know. Until now, if you have any objection, let me know. Small doubt also there, please let me know. Sir, I have this doubt, sir. You ask me, I will help. Ready, sir, I have this doubt. You ask me, I will help. Check everyone. Everything is now clear. Previously, you have doubt. Linker will link here. What is there in that? Loader will load. Linker will link. What is the meaning of linking? So many files are there. Whatever is necessary for this particular program, it will link as a single. So, right, and one more, initially program is there in the hard disk. After completion of all these things, program is there in the main memory. Who kept in the main memory? Loader. Before loading, what you have to do? Packing. That is nothing but linker. Before packing, right? Packing is nothing but linker. Before packing, you should get a visa. Otherwise, you cannot go from one country to another country. That is called assembler. That is called assembler. Assembler will allow you to go from one country to another country. So after got the visa, you have to do packing. That is called linker. After getting the packing, so go to the airport. From there, right, go from India to US. That is called loading. So this is called pre-processing. This is called pre-processing. So careful. Let me know any objection. Sir, I have this doubt. You ask me, I will help. If you have small doubt also there, let me know. Macro definition or shortcut. Macro definition or shortcut. Can we move next? A plus B, high level language. Add R1, R2, low level language. As defined square of x into x. Square of x is a shortcut. Actually is x into x. So what the preprocessor will do? It will replace shortcut by actual. I think you people got it. I think you people got it. Because of it is a first class only. I'm stopping here. After a few days, right? After a few days, I will go so fast. After a few days, I will go so fast. After a few days, I will go to so fast. And if you are a EPT student and you are happy with all EPT classes, you can refer to your friend. You can refer to your friend. You have in your profile, you will find out your referral code. If anyone join using your referral code, you will get the 50% of referral amount. Whatever amount, right, your friends are paying, so you will get the 50% referral amount. So if you are a EPT student, you are liking EPT classes, right? It is your responsibility to ask your classmate to join EPT. It is your responsibility to ask your family member, to your relatives, to your friends. If you like it, you can inform to them. So whatever, if they use your code, you will get the referral amount of 50%. And job guarantee courses also going on. If any fresher is there who is looking for a job, right? Who is looking for a job? If anyone is there who is having some gaps, they can use it. It's a 100% job guarantee course. It's a 100% job guarantee course. So you can contact us. We are going to help you. It's a 100% job guarantee course. You can contact us. We are going to help you. Right? So if you have a career gaps, it is really useful to you. You have a career gap. It is really going to be useful to you. So these are our previous toppers. These are our previous topper. Last year, one of our student Avichal got All India rank 4. Our student Avichal got All India rank 4. In total India, it's the best rank. It is the best rank. 1, 2, 3. 1, 2, 3. They written namesake. They written the exam. So actually, he is the best ranker in the last year GATE examination. He is the EPT student. Right, all his guidance and everything, right, in the form of a YouTube video is already provided. We done so many interviews also. You please go through it. These are our previous toppers. These are our previous toppers. Right. And one more. If you are preparing for a 2026 GATE exam, so EPT is conducting daily test every day. 3 tests we are conducting. Every day 3 tests we are conducting. 1 test for droppers, 1 test for right, 1 test for easy questions, 1 test for very tough questions, 1 test for the medium questions. 3 tests we are conducting per day. Every day we are conducting 3 tests. 1 for the droppers, right? 1 for the very tough questions, 1 for easy questions, 1 for medium questions. Three daily tests we are conducting. Please utilize it. 20 years PYQs with solutions also provided. Short notes and long notes also we are providing. 6,000 verified questions. Free doubt solving. Very important one. Free doubt solving. Free doubt solving. Right? So if you are not joined the group, right, please see the description below. There is a group link you can join. Or otherwise you can ping us. We are going to help you. You just ping us. We are going to help you. You should be there in the doubt solving group because many people are solving doubts. Within 30 minutes only, you are going to get a solution for your query. And the last batch is started. You can join regular course, crash course, or RIC course, test series, foundation course, whatever you want, you can join. If you are a second year person, foundation course. If you are fourth year person, RIC course, or regular course, or crash course, you take whatever you want. And I recommend everyone, I will recommend test series and RIC course you have to take. Everyone I will recommend. Last year from these two, in the right, if you see the question paper, 59 questions came from this. RIC course test series, 59 questions came from, right, last year question paper. So please utilize this. And there is offer going on. If you buy one, you will get the buy one, get 3. 70% discount is going on. 70% discount going on. You can use the code EPT 595 ARJ. You can use the code EPT 595 ARJ. So there is one more offer. Buy one, get 3 offer is going on. Buy one, get 2 also. RIC course, if you buy, test series free. If you buy the regular course, you are going to get the RIC course also, test series also. Totally 3 possible. Utilize whatever you want. 70% discount is going on. Regular course, right? If you want to buy only regular course, you can buy. Or combo regular course also you can buy. Utilize all these things. So our campus placement, if you observe, our students placed. So one student is placed in the Google, one more is in the Meta, one more is in the Hexaway, right? So many people are there. So these are our placement courses. DSA with the system design, programming languages, full stack web development with DSA, full stack app development with DSA, job ready courses also available, right? So all the things you can utilize whatever way you want. Tomorrow at 7:30 we will meet again. Because of it is a first class, I am going slow. Right? So right after a few classes, definitely we'll go very fast. After a few classes. Let me know if anyone having any doubt. Small doubt also there, please let me know. Small doubt also there, please let me know. Yeah, tomorrow we'll meet then. Tomorrow morning there is a discrete mathematics class. If anyone is not attending, they can attend. Tomorrow morning set theory is going on. Don't miss it. It will be really beneficial to you. Don't miss it. Yeah, thanks everyone. Thank you so much. See you in tomorrow's class. If anyone is not started, if you are serious about GATE 2026, I request you, please start the preparation seriously. Please start the GATE preparation seriously. At least now start. At least now start. You can go to crash course. You can go to regular course. You can go to RIC, right? RIC course. You can go to test series. Whatever you want, you can select. If you want, you can go for the foundation course. If you want, you can go for the combo course. All the things which are necessary, we given. It is a crash course. It is a combo course. So this is any doubt there, small doubt also there. I request you, small doubt also there. You can ping us, we are going to help you. You just ping us, we are going to help you. And one more thing is you can use the code EPT 595 ERJ. You are going to get a good discount. Thank you. See you in the next class. Thank you. Thank you, Ella. Thank you so much. Thank you.